system. And if I am going to change the system, and I'll check the coordinates as per the work coordinate system, then we'll be having here we are having the same positions for all the axes. So first I'll check as per the machine coordinate system, these values are 0.1 for all the three axes and 0, 0 for C and D axes. Okay. Now, if I change the system as per the work coordinate system, so we are seeing the same values here, because we have not provided any work offset here presently. Now, that's why if I'm seeing these values as per the work coordinate system or as per the machine coordinate system, they are same, because no work offset is presently active here. So now what we are going to do, we'll just set some work offsets, some values to these axes, so that we'll be able to uh, understand what actually the work offsetting mean to us. So first, we'll also have a look on the work offset table. So here you can see that we have actual values of the machine as minus 0.1, and similar for y and z axis, and 0, 0 for b and c axis. So here we use codes, G codes, for setting these work offsets. So we have a great number of codes by which we set these work offsets. So here you can see uh, we can use a code of G54, G55, G56, G57. So these codes are used to set the work offsets. Okay, actually, after setting the work offsets on a particular code, I'll be activating that particular offset within a program. So here we have a great number of work offset codes available with us, and we can actually set these work offsets as per our job dimensions. If I want to permanently fix a work offset on some workpiece, so I can keep it in any of the code here, and I will call this code in my program. So now, so here our active work offset is G54. So you will see here the values for X, Y, Z, C and D axes all are 0 here. So we have not provided any work offset here. So it means if I am giving any value for these axes, then the moment of the axis will be as per the machine coordinate system, or I can say this time it can be as per the work coordinate system, because they are same, because the values for these are same, because we don't have any active work offset right now. So what I am doing, I'll just put some value here, like for X minus 100, minus 100 for Y, and minus 100 for Z as well. And we'll also provide some angles to C and D axis, 90, 54. So first we are going to move on the XYZ axis. Then we'll provide some rotations also. So here I'll just start the cycle. Okay, the spindle is now moving in all the three directions. Okay, so here you will see These values, as per the machine coordinate system, are -100, -100, and -100. And also, if I check these values as per the work coordinate system, they are the same because no active work offset is present here. So it means that we are just providing the values, and the machine are taking these values as per the origin, the home position, which is this time the uh, home position of the machine, I can say. So now what we are going to do in work offsetting, we are going to shift this home position to some other point, to some other location, or I can say the position of the machine. So I'm going to tell the machine that whatever the values I enter for these three axes, or I can say five axes, so you measure these values from the point which I am going to set on the workpiece. So that will be the origin point, or I can say the reference point now. And I call this point as a work coordinate point. So this is actually the work coordinate system. I am just shifting, or I am just setting the origin point. I am telling the machine that your origin point is now at some other location in the on the work table or on the workpiece. Okay. So to do this process, we are going to use a device called probe that I already discussed yesterday. So we are going to use a probe to set the work offset on the workpiece, and we'll see how it works. Okay. So I'm going to call the probe first onto the spindle, and I will also first load the workpiece on the table. So just give me a minute. So this is the workpiece that we are going to machine. This is actually already machined from all the sides. So this is, I can call it as a block, or I can call it as a cuboid. So I have actually machined all the faces of this workpiece. So it is machined from all the six sides, even from the bottom side as well. Okay. So also I have performed one more operation here called the slotting operation. So these are the open slots here on the two sides of this workpiece. So what I'm going to do, I'm going to load this component onto the work table, uh, and we'll be clamping this workpiece with the help of clamps. So first, I'll just continue my work offsetting work offsetting topic. So we'll see how we are setting the work offset onto the workpiece. Okay, so I'm not going to clamp it right now. I'll clamp it after some time when we are going to machine the component. So for now, I'm just going to set the origin point or the reference point onto this workpiece. Okay. So for that, we are going to use a device called probe. So I will just call the probe onto the spindle, I'll ask the cameraman to focus both the work table as well as the spindle. Okay. Okay. Now the probe is loaded onto the spindle. So I'm going to use this probe to set the origin or the reference point onto the workpiece. So for that, we'll be using some pre-installed cycles. As I already discussed that we are using the Siemens controls here. So we'll be using some of the default cycles for this work offsetting, as well as with the help of this probe we can measure the dimensions of a workpiece as well. So for now, first we'll set the work offset. I'll be manually moving this probe. So actually we need to be very careful while while operating this probe, because it should not there should be not any collision between the workpiece and the tip of the probe. So we have to be very careful, as also this is a very costly device installed on the machine. So the movement this time is in Z axis. So what I'm going to do here, I'm going to make this corner as the origin or the reference point. So for that, I'll first make this side as 0. So this will be our. So first I'm going to make this side as the 0 point of the axis. So we have axis here actually in x and y axis, and also we have got z axis. Okay, so for now I'll be setting this point as the origin point for the three axes, x, y, and z. Okay, so so first I'll make one of the axes as 0. So we are recommended, we have to actually maintain a gap of around 20 mm here, 10 to 20 mm. Only then it is possible that the probe can be operated or the work offsetting can be done. So I'll just start the cycle. And also the ball of the probe should be below the surface of the workpiece, so that it can touch the side where I want to fix a origin point or the reference point. So it should be below the surface, and I'm supposed to check it. Okay, it's good now. So I'm also going to show you the screen so that you will understand what is going on. आराम से सहन करियो तो option or setting the work offset. So what we are going to do will be simply setting the work offset at the corner. Okay. So for that, so here you can see in this picture that to make this side 0, the origin, the reference point for the x-axis. Okay. When the cycle is completed, the machine will make this complete line or this complete axis as this will be the 0 point for x-axis after completing the cycle. Okay. So what I am going to do here, I have selected the probe. So I'm going to set the work offset. I'm not going to measure. I have one more option here as measure only. So we'll do it later. So I'm just setting the work offset. Then the machine is asking which code do you want to use to set this work offset. So I'm going to use G54. Okay. Then I also have to mention the direction here, whether I'm going to touch the component on the left side or on the right side. Okay, in the x-axis. So this is the work offsetting for x-axis. Okay, so if I change the direction here as negative, so I have to touch this probe on the other side. Okay, as I already told you that if we are moving, so actually we follow here a right hand thumb rule. So if the spindle is moving to the right, okay, then that will be the positive direction. Or if the spindle is moving to the left, I'm only talking about this x-axis, okay, then that will be the negative position. So this time my probe is at the left side of this component. So now I'll simply, so what I'm telling the machine that make this point as 0.000. Okay, so the machine is going to set this point, this side as 0. So I'll first just start the cycle. Okay, so here I will first focus the camera on the probe now. So I have just pressed the start cycle button. Now the spindle is going to move this probe. You just, okay. So the probe just touched the that face of the workpiece, and now if you see on the screen, we have got some values that were not present before we started the cycle. So here you can see that the x is minus 304. The value for x is minus 304.926, and for y and z it is 00. Okay. Now Okay, you can now see the main screen here. So if I'm checking the actual values of the machine, they are for X it's 321.043 and for Y it's 253.557 and for Z it is 321.495. Okay. Now I am changing these values as per the work coordinate system. So you will notice here that the Y and Z values, the Y value is same actually. It's same as the actual machine values 253, 253. Okay. But X and Z values are different. Okay. So here now the machine is showing the values as per the workpiece, as per the work coordinate system. But I have not set any work offset in the Y or in the Z direction. Okay. So I think first I will set all the offsets, and then I think it will be more clear to you. So I'll be first setting two more offsets. So for X, it is already set. Now I'll be setting it for Y. So for that, I need to move the spindle to the front side of this workpiece, and then I have to start the cycle. Okay. वहीं से कीजिए, इधर से भी अगर होगा तो. Okay, I'll start the cycle now. The probe is at the right position. Okay, it just touched the front face of the workpiece, and the cycle is complete. Now I have also set it the work offset for Y axis. Now I'm going to set it for Z axis. So for that, we are going to touch the probe on the top surface of the workpiece. So here I'm going to select the Z axis. Okay, the probe is at the required position now. So we'll just start the cycle. Okay, so I have completed the cycle, and the work offsetting for XYZ is done. So I'll just move the probe in the positive Z axis. Okay, so what we have done here, we have made this plane as 0. So this plane is at 0 point in the x-axis. Okay, and also this face or this plane is at 0 point in y-axis, or at I have just set it the values for this plane. I'm telling the machine that this plane is at the 0 position, and this plane is at the 0 position in y-axis. So if I provide some values now here to the spindle, then the spindle is going to move as per the values, as per this origin, as per this work coordinate system. Okay. Now our origin point is at this corner, and also I uh, set here this top surface as uh, it is at the location at I have set it as 0. This top surface means if I am moving the spindle downwards or upwards from this point, then we will be having negative values if the tool is moving downwards, and we'll be having positive values if the tool is moving upwards. Okay, so we'll first check the values on the screen so that we'll be able to differentiate what actually have happened. So I'll first unload this probe. So now I'm moving this spindle to at x0 and y0. Okay, now our spindle, the axis of the spindle, I can say, is at the point. For x it is at 0, and for y also it's at 0. Okay, but if I check the actual values of the machine here, uh, they are for x-axis it's 304 point something, and for y-axis it's 319 point something. Okay, so now these are the values the machine is showing us as per the machine coordinate system. Okay, but if I check these values as per the work coordinate system, then these values are x is 0 and y is 0. Means the spindle is at 0 position in two axes, x and y. But actually the spindle is at this position as per the machine coordinate system. So what I have done, I have set here some work offset. I'm telling the machine that now this is my new origin point where the measurements, where the positions are applied to the tools or the spindle. So now what will machine do? Machine will, if I'm giving some value here, say for example I'm going to give 50 mm for x-axis and start the cycle. Okay, the spindle is now at x50, y0. Okay, forget about z for now. So if I check these values again as per the machine coordinate system, they are different. Okay, so now the machine is taking these values as per the work coordinate system, because with the help of probe I have set the work offset on the workpiece at some point, at some corner. So now the machine is taking these values as per the work coordinate system, but not counting the machine coordinate system. Okay, so it is not giving these moments to the spindle as per the machine coordinate system now, because the work offset is active. You can also see here this it is written here as G54. So this is the active offset currently. Now whatever the values, whatever the movements I am going to give to move different axes, okay, I am going to move y axis to the position 100 and starting the cycle. Okay, now the machine is moving the spindle as per the work coordinate system. Okay, so and also for z axis, if I give here a value of 0 for the z axis, the spindle will touch the top surface of the workpiece. Okay, which I'm not going to do, because it will there will be a collision actually. So I'll provide some positive values like 50 mm. Now the spindle is moving as per the work coordinate system, but not as per the machine coordinate system, because we have now the active work offset here. Okay, now we'll first focus the camera on the work table. Zoom it. फिर थोड़ा zoom. ना फिर थोड़ा नहीं पाती. I just know. Okay, you can see here now. I'm also going to move x to the 0 point and y axis to the 0 or the origin point. Now, now we'll observe here that the spindle is now at 0 points in the x-axis and 0 points, 0 point in the y-axis, and also in the z-axis it is at the location, at the position of 50 mm. Okay, so here what we have done, we have set actually we have set this corner as the reference point or the origin point for the machine. So now the machine, whatever the value I am providing for x, y, and z axis, the machine will move these axes as per this origin point. So here, this corner is now the reference point. Okay, the moments will be from this corner. If so, here we have this time we have x and y at 0 0 and z at 50 mm. So here you can see there is a 50 mm gap top surface. So now if I am giving a value of positive 100 mm in x-axis, going to move, or I can say the tool is going to move, or the axis of the spindle or the tool is going to move in this direction. Okay, in the positive direction. So this is the positive direction for x-axis and this is the negative direction for x-axis. And also if I am going to, if I give some values for y-axis also, say 200 mm plus 200 mm, then the spindle is going to move away from the front side. So in this direction, so it will move. If I'm giving the positive values, it will move in this direction, and if I give the negative values, it will move towards me, towards the front side of the machine, taking this point as the origin point. So we have actually set the origin point or the reference point right at this corner. Okay, and also for z-axis, this is the origin point. This plan or I can say this top face is the origin point for z-axis. So here I have already set a value of 50 mm. That's why the machine have provided the position to the spindle as where it is presently. So this is actually the 50 mm gap here, and I have also provided the positive value. That's why, because if the spindle is moving in the upward direction, then that will be the positive z-axis direction, and if it is moving downwards, then that will be the negative direction for the spindle, or I can say the tool. So here actually we follow the right hand rule. So our right hand rule will be, if the cameraman can focus on my hand here, is my hand visible? Okay, so we actually follow here the right hand rule. Okay, so what the right hand rule tells us, so this is our z-axis, okay, and this is our x-axis, and this is our one more axis here, that will be our y-axis. Okay, so we follow the right hand rule here. So if the spindle is moving to the right in this direction, that will be the positive direction in x-axis, and if it is moving in this direction, that will be the positive direction for z-axis, and if it is moving in this direction, then that will be the positive direction for y-axis. So we follow here the right hand rule. So this tells us the direction, and this is followed for all the machines, I can say. So this right hand rule tells us the positive directions for different axes. Okay, so if I move the spindle opposite to this direction, then that will be the negative direction. Similarly for z-axis, and for y-axis, it will be the same. So here we have set this value. We have now set the work offset on the corner of the workpiece now. Okay, so I can say here we have set the work offset now. So we'll check it. I'll just unload. We'll first going to load the tool onto the spindle. Then we'll confirm whether that is the uh, origin point set exactly at the corner of the block or the workpiece. Okay, so I'll just load a tool onto the spindle. So we'll be loading. I will select the drilling tool because it is pointed and will give us much clarity. This is the drilling tool. I'm going to start the cycle. Now I'm going to give the values for x and y axis as 0, 0. Okay, we'll start the cycle. Now the spindle, the tool is moving towards the origin point or the reference point, I can say. Okay, so this is the point where x and y axis are 0. So the coordinates for x axis and y axis are 0. So here, this is the origin for these two axes, and I'm also going to move the z axis. If I give 0 value here for z axis, it will touch this workpiece. So because this time the spindle is off, we are not supposed to do that. Okay, so I will just provide some 5 mm gap there. Okay, so I'll be giving z as 5 mm and start the cycle. Okay, you can see here, and first I'll show you the screen. You can see here the coordinate for x and y is 0 0. So the tool is at 0 0 position, and for z I have given some gap there, otherwise it will touch the surface. So the tool in the z axis is at a position of 5 mm. Okay, so now this is the origin point for all these three axes. Okay, so whatever the values are now given in a program, I can say, or I can directly enter some values. So the machine will count these values from this origin point, from this corner of the workpiece. Okay, so now I just have to activate this work offset G54 within a program, so that the machine will understand that the values to the tool are measured now from this origin point. Okay, so now the machine is not going to take these values from the machine coordinates. So we can also check the actual machine values here. So the actual machine values are these. Okay, but the movements will be as per the work coordinate system now, as we have now the active work offset on the workpiece. Okay, so we can set this work offset to different positions on the workpiece. We can set it at the center, at the corners, or at some other point. So we have actually got so many cycles here on this Siemens controller. So the first cycle was if I wanted to set the work offset at the corner. Then we can have other cycles like if I want to set the work offset at the center of the workpiece. Okay, so for that I need to follow this procedure. Then we have some more cycles. We have a cycle for alignment of the component. We are also going to do this cycle. Then we can set a work offset of a hole. We can set the origin point of a hole. If a pre-drilled hole is on the workpiece, then with the help of this probe and by following this cycle, we can set the work offset at the center of the hole. Okay. We have other cycles like we have this spigot cycle as well. So here, if we have got some spigot, we can set the origin point at the center of this spigot, whether it is circular or it can be rectangular. So we can set it with the help of probe and with the help of these cycles. So it depends on the shape of the workpiece and depends on the requirements. We are going to set these work offsets. So we have got a number of options here. Okay, you can see here we have some more cycles. If we have a rectangular pocket, then we can set the origin point to the center of this pocket. So actually, we can tell the machine that this will be the center, and whatever the values I am giving for these axes should be measured from this center point. So I can also set the work offset, the origin point at the center of this rectangular pocket. And we have also some options. This is a rectangular spigot. We can also set the origin point at the center of this spigot. Okay. So for that, I have to just follow this cycle. I need to save actually the 4 points P1, P2, P3, P4. Then the machine will automatically set the center of this spigot as the origin or the reference point. Okay. So also we have options like if we want to align two holes. Okay. If we first, I think we'll just do a simple alignment cycle. Only then I think you will be able to understand this part. So we have got a number of cycles here. So now what we are going to do. So first I will do one more cycle on work offsetting. I'll be now setting the work offset at the center of the workpiece. Okay. I will set the origin point at the center now. So for that, I need to touch the probe on the two sides in the x-axis direction, and I need to follow the same procedure for the y-axis. And for z-axis, we don't need to. We just need to touch it on the top surface. So we'll also perform this cycle. Then we'll move forward. So now I'm going to fall the probe first onto the spindle. Now here you can confirm the tool on the spindle is probe, having these dimensions. Okay. So we'll now we are now going to set another cycle. So here I have to use this cycle spacing two edges. What the probe is going to do? It will measure this length and it will divide it into two parts and set the origin point at the center of this workpiece. Okay. So we'll also get the measurements here. Okay. So simply I'll just first bring this probe at this position. So if the surface is flat, I can bring this. I can touch this probe at any point on this surface. Okay, but if it is tapered, then the values may be different. Now the probe is at the right position. I'm just simply going to start the cycle. So we have actually saved 1 point, as you can see on the screen. T1 is saved here. Now I have to move this probe to the other side of this workpiece and touch it there, and the point 2 will be saved there. Okay. Just a minute. Yeah. Okay. Now we are going to say another point. The probe ball is at the right position below the surface. Now I'll just start the cycle. Okay. Moving the probe in the positive z-axis for safety. Okay. Now you can see on the screen that P1 and P2 is saved. Now I have to set this as work offset. Set WO, set work offset. Okay, I'll just touch this icon. The work offset is set now. Okay, so here you'll be getting some values. So here the measured value. The length of this workpiece is 125.493 mm. Okay, also the length is measured here, and also this x0, it is equal to 62.78, means this time the position of the probe, the tip of the probe is at 62.78 from the origin point, and now the origin point is not at the corner, but it is at the center. Okay, now the origin point is at the center of the workpiece, fine, in the x-axis direction. So, and here we have other values. These other values are actually the machine values, the work offset values, the actual values as per the machine coordinate system. So we'll check it now. Now if I provide here some values, say I am giving x as 0, okay, and start the cycle. You will see here now, so the x is at 0 position. Now the work offset for this workpiece now is at the center in x-axis, but not in the y-axis direction. Okay, it is if I also give the values for y as 0 and start the cycle. So first I'll show you the screen. Now at this position now the x and y is 0. Okay, means now the origin point is at the center of the workpiece in x-axis direction, but not in the y-axis direction, because I have only set the work offset at the center in x-axis direction, not in the y-axis direction. Now you can see the position of the probe. Focus, focus. Bus in center. So the origin point is here in the x-axis at the center of the workpiece. Now I'll also show you another angle, so that you will it will be clear that the origin point in y-axis is at the front face. Yeah, पूरा. थोड़ा ये parlor. Okay, so this is the origin point now in the y-axis direction, which is at the left side or the left face of the workpiece from this angle. Actually, it is on at the front face, and for the x-axis, it is at the center. Now, what I am going to do, I will just make the origin point at the center in the y-axis also. Okay, so that our origin point will be at the center of this workpiece. For that, I will just start the cycle. I'll follow the same procedure for y-axis as well. Point 1 is saved. You need to be very careful while operating this probe, because when I'm moving it manually, um, it will not sense the any obstacle within the way, but still we have some safety. Actually, if if there is a collision between the workpiece and the probe, then the machine will automatically stop the movement of this probe. So now we'll be saving point 2 here. Now the point 2 is set. I'm going to move this probe in the positive Z. Now I'll set the work offset. the work offset is set, and the values, the length is 362, and now we'll just check the position. In X, I'm giving X as 0 and Y as 0, starting the cycle. Now, this is the origin point uh, as per the work coordinate system. And also for Z, the top surface, as already I have set it already in the previous cycle, will be the origin point. Now the movements to the spindle or the tool will be as per this point, as per this origin point. Okay, so this was about the work offsetting, how we set the work offset, and how we tell the machine that this is the origin point. So in the similar way, we can set infinity number of work offsets on the workpiece, and we have got so many cycles so for different work types of workpieces for different shapes of the workpieces. So this was all about the work offsetting. Now we'll be going to do some machining. So for that, I'll be first clamping this workpiece onto the table, and then we'll operate some cycle, some machine cycle. So I'm going to clamp the workpiece onto the work table first. Finally, then we are going to use to clamp this workpiece. I will just put this workpiece at the right position. So we are going to use nut and bolts here. So this is a T-shaped nut here. So we'll be using 4 clamps here. So we have got T slots here. Just positioning these bolts at the right position. Clamp 1, clamp 2. So as I already mentioned that we have performed the slotting operation on the 2 sides of the workpiece so that we'll be able to clamp this workpiece directly onto the work table with the help of these clamps. So the clamps are at the right position. So I will tight these nuts enough so that the workpiece is relatively mounted on the work table. So it should be tight enough. Okay. Okay, now the workpiece is all set onto the work table to perform some machining operation. Uh, so now what I am going to do, I'll first set the work offset at the center of this workpiece because I have written a program in which I have set the origin at the center of this workpiece, and then I'll perform, I'll machine this component the top surface will be doing the facing cycle, or I can say the face milling operation. Will remove the material from the top surface of the workpiece. Okay. So before that, because this time I again have to set the work offset, so that because this time the workpiece is not at the same location where it was previously, it is just shifted right or left. So I again have to set the work offset. So actually, I was also supposed to align this workpiece, because we have that option. But for facing operation, it's okay. We can skip that part. Setting the work offset at the center of the workpiece. I have already discussed this part. Now the point 2 will be saved. So I'll set the work offset for x-axis. Now I'm going to take the work offset for y-axis. Now the point 2 is saved. Now the origin is at the center. I'm also going to set the top surface as 0. I'll first set the work offset for xy, and now I'll be setting the work offset in z-axis. So I can touch at any point of the surface, because it's a flat surface already machined. So now our origin point is at the center of this workpiece, and the top surface is the origin surface or the point for the z-axis. So I'll just unload the probe, and we are now going to start a facing cycle here. So we are going to remove some material from the top surface of this workpiece. We are going to give some depths, and for that I have already written a program. So I'll be okay. So I think I'll first run the cycle, and I will give an overview about the program as well. But I think first it is better if we can first show you the screen. Uh, so we are going to remove the material from the top surface of the workpiece. Uh, we call it as face milling. I have already written a program for that. So this is the program. Just a minute. I'll be back. Just hold a minute. So this is the program for the space milling operation. So I'll be discussing it in detail, I think tomorrow. But this time I'm just going to run this program directly. So first we can see here the simulation of this coding. So this is the simulation. This is exactly showing the movement of the tool, how it's cutting the material, removing the material from the top surface. So we'll be running it in single block mode. So you can see here, this is the workpiece. I have already provided the dimensions here, the exact dimensions that we have of that the workpiece is of. So here you can see, as per the coding, as per the programming, the tool will first come at the center of the workpiece at some height. So you can see here, X is 0, Y is 0, and Z is 100. So tool will first come to this position, then we'll see the next block, then it will move to that position. So you can see all the movements, all the values of different x's here. So for X, Y, Z, and for B and C also. And also we have the details of the tool here, the facing tool, and there are some other parameters for the cycle which we are going to operate. So after that, there will be, now the Z is at 5 mm. Then there will be a depth of cut of minus 0.5. Then there will be a movement in Y direction. So Y will be at minus 100. So I'll be going to discuss this programming part tomorrow. So you can see the complete process, how the tool is moving, whether our programming is correct or not, how the material is going to be removed. So all the parameters are shown here, and this is the exact movement of the tool that is going to be given to the tool practically when we operate this cycle. So we'll be removing the material from the top surface. I will directly execute this cycle. I'll start the cycle. Uh, Now we'll be focusing first. Okay, I think it's better. I'll start the cycle and we'll focus the camera onto the front side of the machine so that you will see how exactly the work, the material is getting removed. I'm just starting the cycle. So we will be using the facing tool for this operation. So we are using the coolant here so that the temperature is lowered between the interface of the workpiece and the tool cutting tool. So I'll be stopping the coolant for now. So as per the program, these are the movements given to the axis. So the machine will exactly move as per the programming. So here we are going to remove the material from the top surface. So I'll be using the true coolant supply. The coolant that comes from the spindle, not the external coolant. So the RPM and the feed, it is all calculated. Depends on the workpiece composition, or I can say mainly on the hardness of the workpiece. So I can increase the feed here. So the material is removed from the top surface and the depth of cut here is 0.5 mm. And also the RPM of the spindle is around 670 and the speed is 500 mm per minute. Now it will, so I'll first show you the another angle. So the cycle is going to be repeated again because we are going to remove the material a total of 1 mm depth. So we are removing it in the increments of 0.5 mm. Okay, the facing cycle is over, and we can now inspect the surface quality of the workpiece, or we can actually check the dimensions, whether the dimensions are as per the required dimensions of the workpiece. Okay, so this is so this was a simple facing operation, facing cycle. We have just removed the material from the top surface. Okay, providing a total depth of 1 mm. So now we are going to uh, perform another cycle, another program, in which we have got some machining. We are going to make some spike rods. So for that, I'll be showing you the simulation of the program first, and then I'll simply run the program. So we are not going to perform this three-axis spike rod milling cycle. So the programming part will be discussed tomorrow. I will be giving an overview of this programming. So here we will directly see the simulation of this program, and we'll simply run this cycle. So this is in the single block mode. I'll first change it to auto mode so that we will see what's going on. So this is the final shape, the final pattern, or I can say here we are going to do the spike rod milling operation. So here we have two spike rods. One is the rectangular spike rod, and another is the I can say a contour. So it's also a spike rod. So we'll be machining these two spike rods on the top surface of this workpiece. But so I think the workpiece is aligned. Otherwise, I was supposed to align it, but we don't have enough time. So I think it's okay if there is any misalignment in the workpiece, then that's okay. So I'll be directly running this program. I'll again simulate this program. So this is our spike rod one. Then we'll be making another spike rod. Then this is actually the wall finishing operation that we are performing using different tool. So here we are going to use a milling cutter, the inserted cutter of dia 63, and we are going to use the end mill of dia 10 mm. So I think I'll also show you the top view of this component. So this is the required shape. So we are going to make two spike rods. For now, I will directly just operate this cycle. So this is the main screen, and here also I have actually in a program I have set the origin point at the center of the block, and the measurements will be the positions will be according to that. So I'll just run the program and we'll be showing you the work table. Okay, I have started the cycle. First, we'll change the angle of camera. We'll focus on the front side of the machine. पहले वो पोर्शन फिर इसी पे फोकस करना है इधर. हाँ, पहले आप ये दिखाइए फिर उधर फोकस करिए. Just a minute. Okay, now the cycle is started again. So whatever is in the program, the movements will be like that. So here we are only doing this 3 axis milling. So only there is a movement for 3 axis. We are not moving C or B axis here because this is all C axis. Only 3 axis are here actually operated within a program. So we'll be also doing the 5 axis program tomorrow. But for now, we are just doing 3 axis programming, 3 axis machining. So actually, the tool is moving in the XYZ direction first, then now it is moving in the Z direction. So we actually call it as 2.5D programming. First, we'll check the first cycle, then I'll increase the feeds. Here, the depth of cut is 1 mm. Okay, I was actually because I'm supposed to change the program some parameters because this program is written as per the Z should be 0 there. Okay, that's why there is no cutting. That's good because I already have removed 1 mm material from the top surface. That's why there is no cutting. So this will be a free cycle. Okay, we'll continue this program. It's okay, but there will be no cutting because my Z is actually Z0 is at this point as I have already removed. So I need to start this program from -1 or I have to set a new value for Z. So it's okay. So this first cycle will be a dry cycle. That's why I cut the supply of the. Okay, now some cutting is now the machining is started. So we'll be using some coolant actually. So actually this coolant provides gives us the increases the tool life actually, and also because it keeps the temperature low at the interface, and also the chips are removed at the interface with the help of this coolant. So now the depth of cut is 1 mm and all other parameters are set like the RPM and the feed. Now it will follow. So I'll be increasing the feed. Nice, Madhu. So this is actually the third cycle. The total depth of cut is here minus 3 mm. So the first depth of cut was 3. We won't be so this time. This is actually the second cut. The depth this time so we have given a depth of cut of 1 mm for each cycle. So I'll be increasing some feed here. So what whatever the simulation was, it was so we first saw the simulation. So it will be exactly the practical machining part will be exactly the same as the simulation. So the simulation here is very helpful to avoid accidents and to check whether our program is correct or not. So it will the machine will exactly provide the same feeds, the RPM, the movements to the spindle, what it was shown in the simulation part. So this is actually a manual program machining going on here. So we'll be now making two spigots. So the first spigot will be at a depth of -4 total depth. So this is the last cycle actually. So we can also use the external coolant as well, because not all the tools are come with coolant supply through spindle. Okay, so actually the tool should be like that. So here this tool for this tool we can use both the coolant supplies. So now the first spigot is completed. Now now we are going to machine another spigot. So here also the first cut will be free actually because I have already removed 1 mm material from the top surface. That's why this first cut will be free, but you can analyze this dry run. It's okay, it's good. So I can increase the feed here because it's a dry run. There is no engagement, no machining going on this time. So now the depth of cut will be -2. In total. So now I'm going to use the coolant supply. Okay. The depth of cut is 1 mm, but the total depth is -2. So the movement to the tool is exactly as per the shape of the spike board that we want to make. So these are whatever the size of the tool doesn't matter here. So for every tool, the movements will be exactly the same, whether it is a small tool or a big tool, doesn't matter here. The precision, the accuracy is very high here. So we can provide the movements are actually in microns because this is not the second spike or shape is not an easy shape. It's not a simple one. It's a bit complicated, but we'll exactly get what we saw in the simulation. So I'm going to increase some speed. Now I will. Okay, only actually the total depth of cut was 2 mm, but this cycle is over actually because the first cut was a dry cut. Now we'll be doing some finishing of the walls of these pivots. So this is the finishing operation. So we can just stop the coolant here. We can machine without the coolant. It's okay. So this is actually the wall finishing operation. So we are just performing the finishing of the walls with using the hand mill because we got some bar here at uh, at the edge. So we'll be just doing this wall finishing operation, but we won't be performing the base finishing because that will take much time. So simply so first now this is the wall finishing for 5 or 2. No, no, actually. Barata. या तो इतने ही थोड़ा करो to show. Okay, the program, the cycle is completed. Now the tool will be sent to its to the safe position. The cycle is over. Now we can inspect the shape on the required shape on the workpiece. We can also inspect this while machining. We can just stop the cycle, but now the program is over and we are going to inspect the shape that we wanted to make on the top surface. So first I'm going to remove these chips with the help of a brush. So this is just a bar here. So I'll first so I have also got a gun that supplies the coolant, the high pressurized coolant. So we'll be first removing these chips. Okay. So I'll just clean the surface. You can now analyze the precision, the accuracy, the capability of this 5-axis CNC machine. So how accurate, how precise it is. So what we saw in the simulation, uh, it is exactly as per the simulation, as per the programming we have done, and as per the requirement. So we that was the shape that we required to be machined. So we have got exactly the same shape, the same spigots, the same dimensions, and the tolerance here is in within microns. Okay, so we have got exactly the same shape that we wanted to machine here on the top surface of this workpiece. And this is actually a 3-axis programming, the 3-axis machining done here. So actually the tool movement was in 3-axis, X, Y, and Z. So you can see here, actually we have a here we have a total depth of -3. For this spigot, it is 2 mm, and for this spigot, it is 1 mm now. But I set it as -4 and -2, but I already removed 1 mm from the top surface. That's why here. But we have got here the exact dimensions, the exact shape, and here you can analyze the capability of this machine. So for now, I think we'll close our today's session, and we'll be doing some 5-axis programming tomorrow. We'll be doing T plus 2 axis programming that we call as cycle 800, and on Siemens we call it as cycle 800. So today we have done only 3-axis programming, or I can say that was a 2.5D programming. Now tomorrow we'll be doing first we'll do one program for 3-axis programming. We'll be doing pocket milling, that was a spigot milling, and tomorrow we'll be doing pocket milling programming, 3-axis programming. Then we'll be doing one more program called as 3 plus 2 axis programming, or 5-axis programming, or we can also call it as cycle 800. So this is all for today. Now goodbye. Hope to see you tomorrow, and we'll continue our session tomorrow. So thanks everyone.